Hello everybody, welcome back. Last time I told you that I wanted to show you this time some of the tools that I found for LaTeX regarding biology, and specifically I'm looking for the molecular biology. I am right now in the CTAN, which is the repository for all LaTeX packages, and I found in the molecular biology there are a couple of them. Working with DNA sequences, some graphs that I use for biological tests, TexTshade and TexTopo, and some formats that I use for the Journal of Theoretical Biology. The first time that I tried this is kind of like the fourth video that I'm doing. I tried to show you how TexTopo looked like and how to work with it, but sadly I found that the formats are not working properly. I'm going to try to make something positive out of it and I will show you how to work with TexTshade. So what exactly is TexTshade? If you want to see anything about the package, just go there, read the manual, and the best way for me is usually look at the documentation. But these guys, they have a website, and that is from the University of Kiel. And you can see here, that's what TexTshade does. It shades or colors sequences that have been aligned. In this case are protein sequences. So when you have a documentation, usually it's a PDF file. It tells you what exactly the package is able to do. In this case, it says that it can use multiple sequence alignments from MSF, ALN, and FASTA file formats, which are usually formats that we use in bioinformatics, to show exactly what the alignments are. Then there is the table of contents, and usually you have at the end a quick reference for those of us who already have a little bit of experience with packages, but if you want to find more detail, you will go in the middle. So let us go to the quick reference, and here we are. So there is the TexTshade logo if you want to include it in your document, and this is how the environment works. What it does not tell you here is how to put it in your preamble here. So it says how to call the environment, and you use the use package, any option that you want to use, and the TexTshade. So let us start like that. Let's go here, and we use the use package TexTshade. Good, in the main text. Let us go to the results, and I'm going to add, because I tried this already and I know it does not work with the packages that they gave us, I need to do my own alignments. I look for enterotoxins from Staphylococcus aureus, and I chose 4 of them here in the UniProt, which is a database for proteins. And then I told it align, and then it gave me these results. Now when you said download, it tells you what kind of format you want to use. Since the package says FASTA are allowed, MSF are allowed, and ALN, which I don't see here, then the first time I did MSF, but it did not work. And since I want to show you what it works, I'm going to show you what happens with the FASTA. So when you do FASTA, it shows you that's the file. So you see here it has the information about the protein, and then these spaces are made in a way that when you put these 4 sequences one on top of each other, you will have the alignment that this tool already found. I save it under enterotoxins FASTA, and I save it directly in the thesis. But we want to have everything organized, because yeah, we do it with the figure, so why not to do it with the other file. I place it here on a folder called extra files. So how do we use it? Here they said the minimum example for the insertion of a alignment. So we copy this, we go to results, and let us add it to the results. This is the hyperparameter, which we're not going to use at the moment because this is kind of like advanced. I just want to show you what is the minimum. and we want to add the alignment file. We know it's called enterotoxins.fasta, but it's not located in the results. It's located in the files. And this program is funny because it only works if you give an address where the file is, thinking that you're under the main file. There is no error. Usually other programs will have told me to give the address based on like relative to what the results are. And we know results is under chapters. So in theory, we should have had to do double to get out of the chapters, yeah, and then extra file enterotoxins FASTA. But believe me, it did not work. So what do we see? We see our alignment, and you can see it here. We have as well the consensus. So if you want to remove the consensus is and the consensus is gone. Now there are other options that you can find in the documentation. For example, if you want to show just part of it, and you see here we see only a region up to from 80 to 112, and that's the area that we are showing. What if we want to do other changes? Let's go back here and let's say you can add the ruler, and yep, it adds the numbers above for each of the amino acid position. Or we can tell it show the consensus but a little bit different. And here we have numbers back, the numbers above, because we call it to show the ruler, and we have the alignments and how much conserved they are. It's always necessary to play a little bit to find out how it works. Not always the documentation is perfect. Of course, they don't count that you break, for example, you break the chapters in different files, so probably that was not part of the idea. And it could be, I think, in this MSF file that it is now different from the one that they used to program their package. So yeah, the TexTopo is from the same university, from the Kiel University, and it says that it's being used for something called Rota. And what it does is, if you see it here, it shows the amino acid, each of the amino acids, how it will go through a membrane and will be organized to create a, in this case is a 1, 2, 3, 4, 5, 6, a 6-pass transmembrane protein. And you see that's the N-terminal part, that's the C-terminal part, and it tells you membrane, intracellular part of the membrane, that is the membrane space, and that is the extracellular membrane. Sadly, it's not working. If I ever find a way to make it work, I will show it to you, because even though this is not state of the art, because right now everything is being showed with 3-dimensional forms, it always helps a little bit to see how the amino acids are being distributed along, even though this is only a scheme of how it might be how it might be integrating into the membrane. So I hope you guys have enough now to start to play around and explore your LaTeX and make your thesis pretty. And I think this is the last video for the prep-tober. So I really hope it helps you, and we will see each other for the next one. If you have any ideas that you would like to learn or that I should explore, then let me know in the comments and I'll do my best. Okay, bye bye.